right, let me show you Google AI Studio. Google AI Studio is, in my opinion, a tool from Google that allows you to do many of the same things that you would do with an agent or do with AI agents to develop software or other things if you'd prefer. And so one of the things that you'll notice here is that we have several tools and advanced settings on the side. And what these do is it allow you to tune up the agent environment. So one of the things that I have grown accustomed to here is the use of history. And history allows you to go back into particular chats. And so what the the combined um, some of these chats represent the evolution of what I call Codex Systematica. It's a way of developing software that utilizes some very structured principles as well as some principles in terms of um, code um, aesthetics and code readability. So um, one of the things that I like about Google AI Studio in developing the software is that you can make a copy of an entire chat. So I think that's pretty cool. But also, when you are in the middle of a chat, let's say we go to a middle point and you say, well, I don't really need the entire chat. What I can do is a couple of things. I can take this particular portion of the chat where I'm at. Let me see if I can get right to the middle. I could take a particular portion, let's say this one right here, and I can branch off from there. That will create a copy of this chat up into this point. So I think that's pretty cool. Notice I can also delete portions of the chat. So I can scope the chat more than than I've seen in the past with other interactive platforms, LLM platforms. So this particular chat is was uh, one of the starting points of me building a software system that I call Codex Pragmatica, and it's a system that is in development, and this tool has helped with that significantly. So I have a couple of standards documents that I fed into the chat, right? And that definitely help the language model understand what is needed to be done here. One of the things that I leverage is system instructions. So I got these system instructions, and you can have like there's a library of system instructions that you can have that you can develop, and basically you can have system instructions, and then you can have your prompt, your main prompt that kicks things off. So basically you have two levels of prompting. So the different things that I mentioned in the previous videos, you're seeing them represented here. So let's go to a later stage, right? So one of the things that you'll see at a later stage is that that you can really get into it, right? And so if you have the right standards in place for what you're doing, then you're able to um, develop a pretty comprehensive system, right? And so in this case, I am dealing with a data source that is over 2 GB in size. And this data source, basically, I want to collapse it into an SQL database. And the end result of that is a database that is approximately 500 gigabytes in size. So much smaller than the source data. And at the same time, what it does is it allows me to work with that source data more efficiently. And this process here of developing a extract, transform, and load process, or ETL, to ingest that information um, is one where you need that process to be reliable and ideally to use less memory and use less processor in its execution, and to be developed in a way where if there are errors, those errors are easy to observe and resolve. And so this process of developing this ETL is one where we can essentially develop telemetry that the language model can then use to observe where things have gone wrong and where corrections can be made, right? And so um, the process of actually um, developing this to a conclusion, I found to be very, um, what do you call that, instructive or insightful, right? And so when you get to a certain point in this process where you see that there are refinements that can be made, then what you end up with is a prompt similar to this, right? And so it goes very in depth, and this is the heart of this process, right? And so basically, what we're doing is we're setting up extensive constraints. These extensive constraints, right, will guide the language model in what it is to do as well as what it is not to do. Now, some people have had less success with this approach, and it really just comes down to how you define the prompt, how you define the context. And some have indicated explicitly that maybe they're holding it wrong. Maybe it's a skill issue. Well, here's the way to get beyond that. It's presented right here. This gets you past the skill issue. It's so basically um, what what a definition like this does is it constrains the AI significantly. And when you constrain it in this way, there is an entire swath, an entire batch of bad code that it is not going to consider anymore in what it does, right? Because a lot of bad code is actually defined through easy to use mechanisms, right? Now, a programmer that's hand coding can avoid that, right? Who is an engineer who's really good at what they do, they can avoid that. But their best practices is not on the internet, by and large. Maybe there's some small snippets, but the language model isn't going to learn from small snippets. It's going to learn from the majority. And the majority out there is bad code. So what you do is you reverse that and you constrain it in such a way where there is no way it can consider those bad alternatives. And so what I've done here is I have put in um, a very restricted coding regime, and this allows the AI to basically move more in a mathematical direction, right? Now, a human being actually cannot sustain this type of coding, right? Not at a larger scale and not as a project unfolds. But using a language model, we're able to develop individual code files, right? One at a time, right? Now, it can output multiple code files, right? And, you know, and that's fine as long as it stays within your control, right? Um, and so once you do that, then you can actually implement those code files, you can compile them, and then you can test them. And then when you test them, you generate data, and that data itself is subject to analysis, right? And so one of the things that we can do after that is once we've verified the code, we can then take a look at um, transforming code that is meticulously written, but written in a very what do you call that? Uh, Cognitively hostile way. Code that may be a little bit too rigorous. So then we can go through a process of refining that code into one that a human maintainer can actually work with, right? And so I call that part of the process Codex Pragmatica, right? And so that's a process where you go through a process of having the language model evaluate the code that was written under what I call Autopoetica, which is the more stringent way of writing the code, and then examining what would be the more readable and maintainable um, versions of that same code while keeping the functionality the same. And the result of implementing that methodology, right, where things are a little more loose, right, is that the actual structure of the code itself is rock solid because you developed it under a more stringent um, definition, right? And so you can now safely improve the readability, the flow, the beauty of the code in terms of how a human mind is going to interact with it. And by doing it in that way, that basically comprises Codex um, Codex Systematica, where phase one is you use Codex Autopoetica, which is a very stringent way of defining the code. It is vis-a-vis engineering, right? And then you go through another phase of um, straightening out the code so that it's more readable and maintainable. And so when you do it that way, your intent is not to maintain the code through AI, but simply to speed up its rigorous definition through AI so that you get to a point of maximum productivity and reduced error in your own architecture that you have defined. Another part of this is called Codex Declarativa, right? And what Codex Declarativa does is it allows you to use a shorthand for what you might call a prompt. So here you have your main prompt, right? And so this is your foundational prompt. And this is the prompt that basically defines the universe in which the large language model operates. And it narrows the patterns that it's going to use, right? To just those patterns of code and calculation that should work. But then you have the option of writing just as an elaborate prompt here, but if you have your architecture defined sufficiently, you can actually take a shortcut and define this architectural shorthand syntax. I didn't invent this. This is a well-known thing. Um, to me, it looks like an INI file from the 1980s, but it works and it allows the AI to actually process the tokens more efficiently and also have the right anchors in the right way without getting confused so much about when it comes to more elaborate prose, right? So that's one way that you can do that, and um, it's pretty effective if you have some very sharply defined requirements, right? And so one part of this process that I haven't touched on here, and that I would have to defer going into detail on, is data analysis. So before you even get into any of this, the recommendation is to do extensive data analysis. So the reason why I say that, so if I go back into the initial stages here, one of the things that I did in this process is I did have, or I attempted to have the language model do a large part of the data analysis for me. And I had pursued that path in order to save time. But doing that resulted in a number of errors. And the errors was one of completeness. And there is only so much bandwidth in the language model to look at a large corpus of data that's approximately 2 gigabytes in size. So my human mind can go through that and comb through that. We can run utilities like in Linux, we can run the tree utility and get a output of the entire file structure in a repository and see all the data points that exists, in a broad sense. And we can interrogate into those, and we can start to, um, uh, you can say, summarize some of those areas, or group them and categorize them, so that we can see what the overall data patterns are. A language model in principle could do that, but in practice, for reasons of trying to maintain compute efficiency and trying to, uh, let's say, calculate within a period of time, right, will short circuit that process. An agent might not, but then you will inevitably pay a lot more money to have an agent do that. Now, if you can have an agent do that, then that's different. But if you do it this way, where it's more cost effective for a solo developer, for an individual, right, then this is the process that will allow you to actually define the software more efficiently. But you have to you have to put in the hard work of doing the data analysis. Now, the reason why the data analysis is very important, right, is that the schema for the schema for the data is um, is vitally important, right? Once you have the schema for the data in the form of your SQL database or your primary files, you name it, you can literally drive an entire process, software development process, from the schema data alone. And if you know the schema well, you define it well, then you can actually detect drift or errors in the generation of code through a language model on the basis of that data schema. So instead of trying to understand software code from the surface, from the top going backwards down into entities and domain objects and behavior driven objects in architecture, right? Instead of doing it that way, which actually takes more time, is more error prone, and loses the big picture, you go the opposite direction. You go to bottom up. And this is not a new concept. Steve McConnell talked about this in his book Code Complete 1, as well as Code Complete Edition 2. I've read both editions when they came out. And so these ideas of top down and bottom up, they're at least 40 years old in terms of computer science, software engineering. What I found in practice is that for quick prototypes and impressing investors and impressing others, or just maybe to see how something's going to work yourself, top down is a good approach. It's good for prototyping, and I highly recommend it. But for actual engineering and building good systems, bottom up is going to be the best way to do that. And I say that without reservation. It is going to be the best way to do that. It's one of those few cases where an absolute criteria applies. And so bottom up is the best way. Now, it may not be the practical way, right? But it is the best way to build reliable systems, right? And so that's what you do, is you basically have your schema defined, and then you engage this process. So that's basically Codex Systematica in a nutshell, by way of the tool that I use to apply it. Without large language models, Codex Systematica would not really exist for a solo developer. And so this is a language model driven process, because you're taking the stochastic model and you are transforming it into a deterministic process. It's not 100% deterministic, but you reduce the stochastic aspects significantly, such that you can actually have a higher level of certainty in the generation and development of code. So, with that, I thank you all for tuning into this. And if you have any questions about any part of this, then feel free to ask. But in all things, the best thing to do is just to try it out and see what you can do. People are building things now with AI. Solo developers. There are, well, and not even just solo developers. There are people that don't know software engineering. They're building things with AI. And so when you apply this process both in both cases for the person that knows it and the person that doesn't, then you end up with much better solutions. And that's really my agenda, is higher quality. And so that's why this is freely available as far as information, the content materials, because we want to have a world where we have higher quality technology so that we can move on to the next level instead of constantly having to stumble over these initial steps in technological evolution. So, with that, I will see you on the next one.